All right, we're going to go ahead and get into this. Look, I'm going to be real with y'all. I'm sitting down ready to teach Kubernetes. I have no idea what I'm about ready to teach. I just want to teach Kubernetes for fun, but figured, why don't I just record myself while I'm teaching Kubernetes so that way you can have random Kubernetes fun with me. That's exactly what we're going to go ahead and get started with. We're going to jump into random Kubernetes lessons. Let's get into it. Guys, we're working out of our partners platform. Alta 3 Research was kind enough to provide this platform for our use. And in this platform, we have a Kubernetes cluster up and running. And if I can remember how to type kube control, we'll be on our way. The kube control is our command line interface to a Kubernetes cluster. And a Kubernetes cluster is, well, it's a array, if you will, of virtual machines or physical machines which provide the physical resources required to run our pods. What's a pod? Well, a pod is a group of one or more containerized applications. But what we have in our environment today is two worker nodes, Node 1 and Node 2, which are in a ready position, running Kubernetes version 1.31.4. And so we're going to be working with a fairly recent version of Kubernetes, certainly something that you would find in production in many Kubernetes clusters around the world today. And one of the things that I want to kind of get into as I'm thinking about this live is why? Why Kubernetes? What are we doing here? Why are we learning this? Are we just learning this because someone told you to learn it? And the answer to that question is yes. Yeah, we are learning this because someone told you to learn it. In particular, quite a long time ago, maybe about 8 years ago or so, maybe even a decade ago, there was a particular individual by the name of Jeff Bezos. And Jeff Bezos works for a little-known company, Amazon. You might have heard of it. And the thing is that a long time ago, maybe about 10 years ago or so, Jeff Bezos sent an email out to all of the software engineers and developers in the Amazon mega corporation and basically said something along the lines of, from now on, all Amazon services will be created as a microservice. If you have a problem with it, you're fired. That was the email. Oh boy, that's fun. I like being told that. You're going to do this or else. But that was the email. The word got out that Jeff Bezos had sent this email, and then everybody suddenly thought, well, gee, if Amazon's doing it, and it's that important to Jeff Bezos, then maybe everyone should do it, and everyone should jump onto that Kubernetes bandwagon, and let's get it going. And so why Kubernetes? The basic answer to this question is truly because someone told us to. But was this without merit? Or was there actually any kind of merit behind it? And I'm going to be honest with you, there's a lot of software engineers and developers today in DevOps circles that are going to tell you that Kubernetes is overhyped. Kubernetes is just something that not everyone needs to get a hold of. And Kubernetes is this big honking piece of software that you don't need to get your hands on unless you really, really, really need it. And they're partially correct. Believe it or not, there is some merit to this. There is some merit behind the directive, and that merit is especially useful. This is especially useful for large software deployments. When we talk about large software deployments, I don't want you to think of in terms of many, many, many nodes. But rather, what I want you thinking of is scale. So large software deployments, and this is, again, in terms of scale. Okay? So that's the big thing. Now, when we talk about scale, a lot of times people think Kubernetes involves these very large clusters where you're dealing with dozens or hundreds or thousands of nodes. A node is a virtual machine or a physical machine that provides the resources to run your containerized applications. Okay, that's what provides the physical resources for your containerized applications to function. That is a node. And so typically people think about these large, massive clusters. But the reality is that most Kubernetes clusters are actually quite small. In fact, incredibly small. One of the things that I like to talk about, especially when we're addressing big myths about Kubernetes, because yes, the criticism regarding Kubernetes is certainly valid at times, it's not necessarily accurate. So, for example, if you've been around LinkedIn and you're in DevOps circles at all, you have probably seen every single bot on the face of the sun talk about how you don't need Kubernetes solutions. What you need is serverless architectures, and go this way instead. We could talk about that. But there's a myth that Kubernetes is this massive beast which is difficult to tame, and that's just simply not true. Think about it this way. Can you imagine Kubernetes clusters running inside of a fast food restaurant? A fast food restaurant. Like a Chick-fil-A or something. Well, you better start imagining it because it's true. Chick-fil-A restaurants have a Kubernetes cluster in every single one of their locations. They run a 3-node physical machines cluster on-prem in every single Chick-fil-A restaurant. And these are little Nook nodes. They're not big honking machines. They're just simple little, basic little Nook nodes. And the reason why they do this is because they want to be able to have every restaurant host their own software services and not be dependent upon a central data center somewhere in which if the restaurant were to lose internet, they would not be able to function. So Chick-fil-A restaurant locations everywhere serve up their own Kubernetes clusters. And so if we can deploy Kubernetes solutions in a Chick-fil-A restaurant to locally serve software servicing that one location, then where else can I put a Kubernetes cluster? And what you're going to end up finding is that you're going to find Kubernetes clusters everywhere. And it's for very good reason. It makes managing localized physical infrastructure a breeze. Think about it this way. Telecommunications is another big place as to where we need Kubernetes. And the reason why is because we need to manage a 5G and a satellite telecommunication infrastructure. What's the big difference between 4G and 5G? A lot of people, consumers like you or me, probably didn't notice much of a difference from the 4G to 5G jump. Speed's certainly better, yes. But the biggest thing that we got was far more reliable service. And what was the hardware that was involved in differentiating 4G and 5G? Guess what? It was Kubernetes. So now all of your 5G telecommunication towers, they now come equipped with, you guessed it, a physical Kubernetes cluster. And then we have to manage that cluster from a centralized workspace. Typically, it's done via Rancher or other tools. But essentially what we're able to do is we're now able to provide a multi-cluster application, not just a multi-container application, a multi-cluster application. And so when we get into the heart of it, when we get into the why Kubernetes, I don't want you just thinking about horizontal auto-scaling or probes or failover or just actually being able to scale out as opposed to scale up. But if you don't understand all of that, I might get to it during this random Kubernetes lesson. Okay, this is all random. I don't have a script, okay, guys? So I might get to it. But the big thing I really want you thinking about is, when do we have this need for multi-cluster applications? And how do I manage that? And it's a big CI/CD DevOps question. To answer that question, you're going to need to have knowledge of what is a container, right? What is containerized or container application orchestration? How does that even work? How do I deliver containerized applications? How do I update them? Now, how do I set this all up in a CI/CD pipeline? There's a lot of things you got to know. Now, chances are you're not a DevOps engineer, but you've been told you need to know and understand Kubernetes. So the question that I really want to approach this in, if we're going to really think, why Kubernetes? Why am I interested in this? Let's go ahead and change the scope of our audience a little bit here. All right? Let's say I'm not talking to a DevOps professional. Let's say I'm talking to a software developer. So you're writing code, and you've been told you're going to have to write your code into containers. Darn it. You know, we've been developing codes in terms of monolithic applications, in terms of service-oriented architectures. And the way we write code for monoliths or service-oriented architecture is very different than how I would have to write code for a microserviced architecture. And so if we're thinking about why Kubernetes from a software developer point of view, which is what we're talking about today, you're going to hate it. Okay, it's just true. I've never met a software developer who loved this. I know systems administrators and DevOps guys love this stuff. Developers, not so much. It's confusing, doesn't make a lot of sense. But when we really brass tacks it, suddenly it becomes a necessity and you're going to like it. I promise. You're going to hate it at first. Okay, so let's put that caveat. At first, okay, at first glance, you're going to hate this. And the reason why is because it is a philosophical difference. Philosophically, we've been developing software in a particular way where I know where my services are running. I am used to scaling up, not scaling out. I'm used to treating my infrastructure like a pet and not like cattle, where it's disposable. So now that we are introducing the idea of disposable nodes, and not just nodes as in like a virtual machine, but now we're saying, nah, the application itself is disposable. The microservice can die at any point and then come back to life on a different machine with a different IP address and still function. It's a philosophical difference because now the way in which we write code has to take in those particular parameters, those particular issues. How do I account for this? How do I get a process, which I'm used to being able to talk to another process through kernel space using inter-process communication? Now I got to get these two processes talking over network, but doesn't that cause latency? And what other considerations do I have to worry about now that I'm working in a microserviced world? It flips the script. It is a complete and total 180 on the philosophical approach to writing code. And here's the next big thing. Not only are you going to hate it, you're going to be told to hate it. I see it everywhere. And a lot of the comments and a lot of the hate about Kubernetes that I see typically comes from software developers. And it typically comes from people who do not quite understand the why. And they are very resistant to change, which, guys, we're human. We're creatures of habit. Change is hard. We don't like it. There's a reason why Bezos' email was very strongly worded. Okay? You're going to get fired if you don't do this. Okay? Well, darn. So now what do? How do we deal with this? Okay, well, we deal with it in a couple of different ways, right? One, we get training. Training from whom? Hopefully from us. Okay, we'll get you on the right track. But the thing is that you're going to need to get training because you're going to need to understand what are the considerations and what do I have to think about when I'm working with the Kubernetes cluster. So you need training. We got to wrap our heads around this, okay? What is Kubernetes? How do we get a multi-container application working together, orchestrated over a pool of nodes? This sounds like an infrastructure nightmare. It isn't. And what kind of software are we talking about with Kubernetes? So this leads me into our next topic. Go ahead and screenshot these notes real quick. Give you a second, and then we're going to move on. So the next thing I want to talk about before we get too much more into any hands-on learning, okay, is let's just do a couple very basic things. First off, what is Kubernetes? Kubernetes is oftentimes referred to as a container manager. This is wrong. Okay? Kubernetes does not manage your containers. It could care less about your containers. It's not interested in your containers. Or what does it do then if not manage containers? It is a container orchestrator. Okay, hold up. Tim, are you just going crazy? Are you just going nuts here? What's the difference between an orchestrator and a manager? Well, if you've ever been in a band, yes, I was a band geek back in the day. My instrument of choice was a flute. It's what I played. I had a number of different instructors teaching me how to play the flute. And eventually, I ended up becoming a section leader in the band, and I was the manager of all of the other people who played the flute. I was the manager. It was my job to make sure they were learning how to play the pieces that they were working on, to make sure that we were all in tune, to make sure they had mentorship and guidance. Me, as the section leader, was the manager of all of the other people who played the flute in my band. Neat. But what was the conductor's or the orchestrator's job? The orchestrator did not care about the day-to-day management of every single person who played flute. That was my job. His job was to combine our respective instruments and the sounds they're in through conducting an orchestra, leading us, right, into battle or into our performance, if you will. I managed the nitty-gritty of the section. The conductor orchestrated us and turned each and every single instrument into part of a larger composition, which was the music that we played. Orchestrating can be all sorts of different things, from writing the music to actually orchestrating a symphony to actually conducting and leading the orchestra in a live performance. So that's what we're really talking about. When Kubernetes is a container orchestrator, it could care less about your containers. Okay? Period. It could care less about your containers. What Kubernetes does is it is a pod manager. So now we have to ask the question, okay, so what is a pod? A pod is simply defined as a group of one or more containers that are deployed together, that are deployed as a unit. That's the better answer to this. And this is where we're going to get into some really cool nitty-gritty technical stuff, okay? Well, what is a container? I've heard a lot of really bad definitions for what a container is. Oftentimes, you hear people comparing a container to a virtual machine, which isn't only inappropriate, it's wrong. There is no comparison between a container and a virtual machine, and people need to stop making that connection. It is just technically wrong. So when I ask the question during class, well, what is a container? Someone typically says a virtualized process, something along those lines. And I say, well, what is a container actually virtualizing? And that's about the sound that follows the question. A container is not virtualizing anything. We could talk about a container network interface here in a minute. Because those of you who are like, oh, you're wrong there. No, hold on. We'll talk about CNI later. But a container is not a virtualized anything. A container is an isolated process. So when we talk about a pod, we're talking about a group of one or more isolated processes. And these isolated processes are isolated, let's click it over this way a little bit, isolated along 7, count them, 7 namespaces of isolation. Okay, so what are those 7 namespaces of isolation? Well, we got everything from C group, which is memory and CPU reservations and limits, right? The next thing is going to be mount points. So mount, and this is going to be everything from file system, okay, to actual mountable drives, mountable volumes, okay? So file system to mountable volumes. They have their own file system and their own mounted devices. They're going to have IPC, that stands for inter-process communication. And what that means is that a container cannot communicate with other containerized processes or other processes on the host through the kernel space. Can't do it, because it's isolated there. It cannot make that connection via the kernel space. We have to communicate now over network. And so that's another namespace of isolation. And then, of course, we're going to have to talk about process ID, right? That's just they have their own process IDs. They're going to have their own user and group IDs. So UID, group ID is for your own users and groups. And then we're going to have, of course, we got to talk about network. So a container is going to have its own network stack. So that includes IP address, ports, etc. Okay, and then finally, number 7 is something called UTS, which is Unix Time Sharing System. That's Unix Time Sharing System, which is a fancy name for host name and NIS domain name. Okay, so that's what that is. That is a container. It's just an isolated process, which is isolated along 7 namespaces of isolation, and there they all are. That's a container. Any other definition is wrong. I have a habit of doing this, guys. Okay? I am a critic of today's technical instruction. I think people tend to have a problem. I'm going to make my body disappear here so you can see that last little bit of a note, an IS domain name. I have a tendency to be very critical of how we are teaching technical topics today. Okay? This is no exception. Okay? So the way we've been teaching containers is just simply all wrong. Has nothing to do with virtualization. Has nothing to do with virtual machines. We're just talking about isolated processes. You can run a container on a physical machine, on a virtual machine, on Raspberry Pis or whatnot. Heck, these days, now we're trying to build stuff on quote-unquote serverless architecture, in which you spin up containers in the cloud. Never mind the fact that it actually is using Kubernetes. You just don't manage it. But hey, that's a whole other topic. The big thing is that right now what we're talking about with containers, and we're talking about building out containers and the 9 and what we're actually doing with Kubernetes, is that we need to co-locate containers onto a pod. And by doing this, we fundamentally change how containers work. So pods, okay, this is where things get fun. Pods fundamentally change the way containers function. Would change the name of the game here, guys. And why is that? It's because pods, or rather containers on a pod, share 3 namespaces of isolation. They share IPC, so now every container on a pod can directly communicate within the kernel space with any other container on the pod. So this allows for fast process communication via the kernel space, okay? They also share network. Okay, so this is going to be our shared IP address, right? So they're going to have one IP address for all the containers, and then we're going to have a UTS, meaning they're going to have the same host name and NIS domain name. Okay? So now our containers on a pod, all of the containers that are on a pod together, they are now fundamentally changed. They are able to communicate with one another via the kernel space for fast data moving. They're able to have the same IP address, and they're able to have the same host name. They will have the same host name. They will have the same IP address. Just to be very clear about that. They will have the same. Oh, wow. Okay, that's fun. Pop quiz. How does one container on a pod get the intended connection over network versus the other container on the pod if they share the same IP address? Answer, port. Those containers will be exposed on different ports. Okay? And so we'll target a different port in order to match which container we actually want to talk to. That's a fun little networking conversation there for you. So now what we got is an understanding that Kubernetes is a container orchestrator. It doesn't care about your containers. It manages pods. And a pod is simply a group of one or more containers that are deployed as a unit. We refreshed our memory as to what a container actually is. It's simply an isolated process. That's one part of the container definition. The other part is that it can be packaged idempotently and deployed predictably as a result of its packaging. That's important to mention too. And then finally, pods fundamentally change the way that containers actually function. So now that we've had a chance to kind of get under the hood, let's finally define what is Kubernetes. Kubernetes is a pod manager which schedules pods, a collection of containerized workloads over a pool of nodes known as a cluster. That is what Kubernetes does. That is the full definition as to what is Kubernetes. Kubernetes is a container orchestrator. It manages pods over a pool of nodes. Neat. Go ahead and screenshot these notes, and we'll press on to our next big topic. And the next big topic is, okay, now I know what Kubernetes is. It's a way for me to deploy containerized workloads organized as pods across a pool of nodes. That's what it enables me to do. I understand fully what a container is now, and I understand fully what a pod is and how it fundamentally changes the way containers function, which gives me a complete answer to the question, what is Kubernetes? Kubernetes is a pod manager which schedules, orchestrates pods, a collection of containerized workloads over a pool of nodes, which is known as a cluster. Kubernetes training is often way too expensive and you have no idea where to begin. What if it could be cheap and you knew exactly where to begin? Well, that's where InfraOps Guild comes into play. So the thing is that our Kubernetes training is the same Kubernetes training that the Fortune 500 companies pay thousands of dollars for a seat, but you can buy it from me directly at $250 a pop. Our classes take place in the evenings at times that is convenient for you and life in general, and it's affordable. We use a live platform. We have over 50 labs in our complete Kubernetes application developer courseware in part 1 and part 2. So you know you're going to get that hands-on experience and get set up real nice and easy for you. And you're going to get 3 hours of live instructor hands-on in the classroom every evening from 7 p.m. to 10 o'clock p.m. Eastern Daylight Time. So be sure to come on in and join us. Part 1 of our Kubernetes application developer course will be from September the 22nd through September the 26th between 7 o'clock p.m. and 10 o'clock p.m. Eastern Daylight Time. And part 2 will take place in October, on October the 6th through October the 10th, also starting at 7 o'clock. Thank you guys so much for watching, and hey, be sure to join us. We've got a lot going on in this class. We're going to cover every single certified Kubernetes application developer topic in the exam. And we're also going to have a practice exam for you free of charge, same price. Get into one of these 2 parts and enjoy it. In any particular case, guys, I hope to see you in the classroom soon. You guys have a good one. So now that we understand what Kubernetes is, let's get into the myths of Kubernetes. Kubernetes myths. We need to fix these because the truth is that there are a lot of myths out there, and application developers, I'm looking at you. You the guys are, you're the ones who are perpetuating these myths uncontrollably, and it hurts. It hurts my brain and it hurts my soul, and I don't like it. Because Kubernetes is actually something amazing and something that you should actually pay attention to. Something you should actually want to use. So let's discuss some Kubernetes myths. The first Kubernetes myths is that Kubernetes is heavyweight. It's massive. We already discussed this, right? Kubernetes actually works best when it's small, because the idea is that I want to have a multi-cluster application, not just a multi-container application. We're already in the world of multi-cluster applications, guys. Telecommunications, Chick-fil-A, okay, guys? Satellite communication, internet that's delivered to your airplane requires Kubernetes clusters on airplanes. That is a thing. Utility companies are now using Kubernetes. Those are very heavyweight, though. We'll talk about those later. But the point is that Kubernetes is becoming everywhere, and its best deployment and use case deployments are when we are scaled very small. And that's the way we like to run. And so the idea here is that Kubernetes is best deployed as a collection of small clusters. Okay, so when we talk about small clusters, you could think about things like telecommunications. You could talk about, for example, Chick-fil-A. They do this very well. And then you can also talk about satellite communications, or rather, just to be more specific, 5G cell towers do this. And the idea is that I need to support an application not from a large centralized data center, but rather from local deployments that are all over the place. So think about every Chick-fil-A restaurant you've ever been to. They all have Kubernetes clusters, right? Those are very small, on-prem, localized deployments. This saves Chick-fil-A a ton of money, by the way. And it enables each and every single one of those restaurants to be run independently of a large central data center. And the cool thing is that you think that every single Chick-fil-A restaurant has a Kubernetes engineer ready to rock and roll and knows how to work those things? Yeah, no. That's not how it functions. That's not how it works at all. Right? When we're ready to push an update to those machines at Chick-fil-A, it's pretty sure it's just a thumb drive that goes in there and runs a batch process and gets it done, right? Maybe an actual playbook, something along those lines. It's real simple, okay? It's nothing too complicated. So we have high-tech and low-tech spaces, and Kubernetes is the primary enabler of high-tech and low-tech spaces in this particular case. And so what I really want to do is to kind of shift the perspective, because I think when everyone thinks Kubernetes, they put in their mind cloud-based computing. No. Don't think cloud-based computing. Think bare metal on-prem. That changes the game. That is a different way of thinking about Kubernetes. And by the way, that's where your most successful Kubernetes deployments are in the world. You're surrounded by Kubernetes clusters, and you see them every single day, and you don't even realize it. So that first big myth, Kubernetes is heavyweight. It's massive. Get that out of your head. No, that's wrong. That's wrong. That's not true, not even in the slightest. Let's keep going, okay? So now here's the next one, number 2. Networked traffic in Kubernetes makes too many hops. Increasing latency. Increasing network latency. Interesting. That is an interesting thought. I will once in a while entertain the discussion that Kubernetes is overblown, overhyped, and inappropriate. And way too often, this is the first thing people like to talk about. That network traffic in Kubernetes makes too many hops, and this increases network latency. So, sure, if you don't know how to use Kubernetes, this could potentially be true, but in reality, Kubernetes kind of takes care of this problem for you. And here is the reason why Kubernetes takes care of this problem for you. Kubeproxy. Kubeproxy is a service installed on every node in your cluster. Okay? And what it does is it fundamentally acts as a redirection service, where packet forwarding occurs in the kernel space, so it's super fast, and it maintains all routes and net filter rules. Now, depending upon your container network interface, Kubeproxy will be configured differently. Okay, so for example, if we were talking about Linux-based clusters, right, we would have something more than likely like Calico. Calico is a great bare metal Kubernetes CNI, or container network interface. That CNI is what fills out the Kubeproxy routes and net filter rules, okay? It manages Kubeproxy. So depending upon your container network interface, Kubeproxy gets built a little differently. But in Calico's case, it's built using Border Gateway Protocol. So it's all one autonomous system, typically a network run by single ownership, in which everything is on the same subnet. And when we're running like that and we're doing packet forwarding within the kernel space, guess what? I don't care if you're hopping twice, if you're hopping 8 times, if you're hopping 24 times. When you're in such a solution, you're dealing with traditional, very, very, very low latency and or response times. Okay, I have seen network communications via various tap tests which return in less than a millisecond. It is very, very fast. But then the next problem is well, okay, if I'm running in a microserviced world, then one container might need to send a lot of network traffic to another container because they can't communicate via IPC, or inter-process communication. And that can cause latency. And my answer is, yes, you are correct. And this is a problem that we commonly see in service-oriented architectures, in which we're building off of primarily a virtual machine backbone, right? But we have a solution to this problem. unlike in a service-oriented architecture world. So say, for example, I have the problem, I require significant network traffic between two pods. How do I solve this problem? How do we do it, everybody? Think about it long and hard. We just got done talking about this. What is a container? It's an isolated process. One of those namespaces of isolation is IPC. What does a pod do to the interprocess communication namespace of isolation? What does it do? It beats it down. All containers on a pod share IPC namespace, which means that now if I were to put those two containers together on the same pod, they could communicate via IPC, thus defeating the network argument. So now those two processes are communicating as though they're on the same container. Nice. We solve this problem by co-locating the two containers onto the same pod. Oh. And so network traffic in Kubernetes makes too many hops, increasing network latency. Suddenly sounds like, no, wait a minute. I'm sure some of you who have worked in service-oriented architecture worlds, like I have, could suddenly think of situations in which co-locating containers onto the same pod will suddenly fix the problem. Yeah, doesn't take too much thinking to get this done. Now, application developers, this conversation is targeted at you. I'm talking to you, application developers. Who enables this? You do. Okay? So when we are having a systems engineer and they're making planning and design decisions and they decide that we need to co-locate these two containers onto the same pod, they're going to look for an IPC solution where these two containers are interacting with one another via the kernel space, not network. That is solved at the code level. You need to be mindful of this. Okay? You're the one who implements this solution. So do bear that in mind. So, two big Kubernetes myths. Kubernetes is heavyweight. It's massive. Number two, network traffic in Kubernetes makes too many hops, increasing network latency. Now here's number three. Number three. You guys ready for this one? I know you've heard this one. Kubernetes is complicated and difficult to learn. Really? I'll be one of the first people to tell you that if an idiot like me could figure it out, anyone can. And I mean that very sincerely. Here's the deal. Kubernetes actually simplifies a lot of things. So I came from a service-oriented architecture world. I used to work in highly secure spaces with very demanding customers, okay? That was the world that I lived in a decade ago. A lot's changed over the last decade. A lot has changed. And I remember being challenged frequently because I was dealing with a backend database that was storing petabytes of data. And we had on-prem data center that I had to visit on a regular basis. And we were running things as a service-oriented architecture, so we had multiple virtual machines, and we were dealing with many of the problems that I actually just discussed above. And what I found is that Kubernetes simplified the whole thing. It simplifies canary deployments. It simplifies rolling updates. It simplifies and enables DevOps best practices. It enables me to keep my software and my services running so that way my clients and my customers who utilize my software have no downtime or near zero downtime. What I have found is that Kubernetes almost makes this entire thing so easy that, yes, even a caveman can do it. It is simple. The problem And the reason why people get the concept in their mind that Kubernetes is just difficult to learn is because it does philosophically shift the way we think when it comes to deploying applications. It shifts everything. It changes the whole game. It's hard to learn. It's not hard to learn. It just challenges the established norms. So this reminds me of a conversation that I had a long time ago. I'm going to go ahead and jump onto a soapbox here for a little bit. Back in 2018, 2019, I attended Game Developers Conference in San Francisco, and I had the opportunity to meet who was at the time the product manager of Microsoft Azure, in particular Microsoft Azure Kubernetes, or AKS. Very good friend of mine, and when I began teaching Kubernetes 3.5, almost 4 years ago, I gave him a call. And I said, hey, bud, I'm getting ready to start teaching people how to use Kubernetes, and I'm ready to jump onto this new endeavor, and we're learning. It's great. What's the first thing I need to tell all of my students? And I'll never forget his response. His response was very simple. He goes, that's easy. Don't. Just tell all of your students to not. Not bad advice, especially at the time. In fact, that advice was very, very valid the more I think about it. The reason why that advice is so valid is because he was struggling with a particular client. And this particular client did not know Kubernetes, had no desire to learn Kubernetes. They were trying to microservice their legacy application, but they had no clue what they were doing, and they didn't want to take the time to learn Kubernetes. They were trying to put the check in the box. They were responding to the ultimatum, if you will. And in the process of doing so, they try to reinvent kubeproxy. We just talked about what kubeproxy was, right? In fact, it was on the board just a second ago. It's a service that's installed on every node in your cluster. It acts as a redirection service. So we've got packet forwarding occurring within the kernel space, right? It maintains all of our routes and net filter rules. They were trying to reinvent kubeproxy. And the reason why they were trying to reinvent kubeproxy was because they were trying to create the idea of a stateful container, or a stateful set, a stateful pod, if you will, where you had a pod with a consistent network identity. That cannot happen in Kubernetes, because if a pod dies and then it gets respawned on a different node, guess what? It's going to have a different IP address. kubeproxy is what tracks those endpoints for us, so we don't have to worry about it. So they were reinventing the wheel because they did not understand how Kubernetes services, namely kubeproxy, functioned and the role of CNI, or Container Network Interface. They didn't get it. And so they were trying to reinvent the wheel. When they were reinventing the wheel, they were creating all sorts of problems for themselves. And my friend told me, just tell them not to bother because they're not going to take the time to learn. I remember this was 3.5, this is more than 3.5 years ago that we had this conversation. So, okay, he was a little frustrated at the moment. And I told him, I said, well, that's the problem that I am looking to address. That's the problem I am seeking to fix. Because the deal here is this. If I can simplify the Kubernetes learning experience and get people to understand Kubernetes for what it is, break down these myths and get people utilizing Kubernetes the way it's designed to be used, then we solve your problem. Because the problem that he identified with Kubernetes, what's wrong with Kubernetes, was the real problem with Kubernetes. Kubernetes has a training issue. And it's not that it's complicated to learn. It's not that it's difficult to learn. It's that no one is taking the time to learn Kubernetes correctly. That's the problem. So as we are coming up to the end of this 50-minute random Kubernetes lecture in which we discuss why Kubernetes, what is Kubernetes, and Kubernetes myths, and I didn't even get into any kube control commands or how to write pods or any of that fun stuff. We'll get to it in a future lesson. It's whatever, okay, guys? But the point is this. Kubernetes does work. It works correctly. None of these myths are true. They're all patently false. The problem is that developers are not taking the time to learn Kubernetes. Developers think Kubernetes is a systems administration problem, that it's a DevOps problem, that it's a site reliability engineer problem, that's a systems engineer's problem. It's a project manager's problem. It's not their problem. No, it is your thing to learn. You need to learn Kubernetes if you're developing microservice applications. You have to understand it. You need to be able to run kube control commands, and you don't need to be lost when looking at your architecture. It's really easy. It's not hard. All right, you guys understand coding languages. You make computers do incredibly complex operations. You could figure out Kubernetes. Okay? Kubernetes is nothing more than a collection of bash scripts that just run real good. It's pretty basic stuff. Okay? So with that being said, get the training. And certain providers, like the InfraOps Guild, hello, hi, we make it really cheap for you. $250 gets you into a week-long class, 7 to 10 o'clock p.m. Eastern time, from September the 22nd through the 26th. And part 2 is going to run October the 6th through the 10th. And in those classes, it's entirely hands-on. We're going to break down all the control plane components, everything that makes Kubernetes tick under the hood. We're going to get into not only the why and the rhyme and the reason, but the how. The way we teach Kubernetes here at the InfraOps Guild is exactly how we would play in the real world. We practice like we'd play. Okay? And our platform is entirely enabled by Alta 3 Research. Alta 3 Research, if you are familiar with them, then you've already experienced incredibly good training from my peers or myself. You know this is the same training that the Fortune 500 companies spend thousands of dollars for. You get it for $250. Head on down to InfraOpsGuild.com. Yes, of course, naturally, I'm going to give you free lessons on Kubernetes. You just sat through one, and if you enjoyed the free lesson, go jump into the paid lesson. Those are planned. Those have labs. Those get hands-on. This is just random fun that I'm going to do once in a while to help market what we do professionally, okay? I get to talk about things at a level I don't normally get to talk to in these longer form videos, which is real nice. So in any particular case, guys, come on by. Check out the class. I hope you enjoyed this. I'll be back with more of this. I want to do more Kubernetes training on the fly, just like this, random. Maybe next time we'll talk about what is a pod? How do we actually develop a pod? What is a manifest? What's up with YAML? I've actually seen people complain about YAML. You know, the superset of JSON that was literally designed to be human readable and writable. Yeah. People have a hard time with it. Let's talk about it. Let's teach YAML. We could do that. So come on by, stay tuned, and don't forget to join our social platform Discord. Links are in the description below. Feel free to reach out to me anytime via our Discord channel. You can find me there, and I look forward to hearing from you. Sign up for a class today and all that other fun stuff. I don't need to talk anymore. Guys, thanks for joining me with this random bit of training. I'll see you guys next time.